So we're going, guys, we're going over piecewise defined functions. And we're going to start by kind of reiterating what you should have taken away from yesterday's notes, okay? So I want you to be in a good learning position. That means removing your AirPods, earbuds, putting your phones away, paying attention, and asking questions when you are confused. Okay? All right, so yesterday you should have learned that a piecewise defined function is a function made up of different formulas or rules, okay? Depending on what x is, okay? How that works is that you have an expression and its interval, another expression and its interval, another expression and its interval. A piecewise doesn't have to be 3 pieces, it's 2 or more pieces, okay? And they do not have to connect. So this is an example of a piecewise function that connects. Do we see that? Yeah. This is an example of a piecewise function that does not connect. Okay, it is still a function, and each x value is still defined on the interval. Does that make sense? Okay, and it cannot be defined in 2 locations, or it would not be a function. So if this was a closed circle and this was a closed circle, then this would not be a function. It would be a relation. Does that make sense? Okay. Also from yesterday's video, you should have taken away that if it's strictly less than or equal to or greater than or equal to, it's going to be a closed circle. If it, I'm sorry, less than or equal to, greater than or equal to. If it's strictly less than or greater than, then it's going to be an open circle. Yes? Yeah. Okay. So here, the other thing is your intervals tells you where your function is broken, where the pieces begin. So this one only has one breaking point, and that's at x equals 0. Do we see that? Mm-hmm. That's where I have a function to the left and a function to the right. Agree? Mm-hmm. Okay. The function to the left here is linear. The function to the right is a quadratic. On this one, my breaking, I have 2 of them. I have one at -4. And I have one at 2.
Well, what's the function
okay.
Of these brownies right here?
May you please be quiet? Seriously. Okay. So here is our other breaking point. This one isn't affected because there's nothing that follows before it. But we have here at 2. And notice here, the values are not the same because when they both aren't shaded because we're a function, not a relation. All right. Now, we're going to go through 3 parts. We're going to do part 1 of evaluating, part 2 of writing. Okay. So part 1 of evaluating is identifying where does a value fall on the intervals and which interval it's going to use. So I'm going to label them as 1 and 2. So this is expression 1, expression 2. And you're going to tell me, does it fall in 1 or 2 when I say the value? Okay. So if we have P of 1. Where does 1 fall? And which interval does 1 fall? So in expression 1, right? Yeah. Because 1 is between 0 and 5. So that means I would use the expression 3x plus 5 to evaluate P of 1. So this would become 3 parentheses 1 plus 5, which is just 3 plus 5, which equals 8. Okay, where does P of 5 fall? Expression 1 or expression 2? 1, because that's where 5 is equal at, right? Mm-hmm. So I would use expression 1 to evaluate. So we have 3 times 5 plus 5, which equals 15 plus 5, which is 20.
This actual pre-count is still in the algebra.
Okay, P of 10, where does that fall? In expression 2, because 10 is greater than 5. So that gives us 10 squared minus 3, which equals 100 minus 3, which equals
97.
97. Okay, and then P of -6. Does it fall in either one of them? No. So since it doesn't fall in an interval, that means that there is no solution. How do you feel about evaluating?
I don't know yet.
Okay, I'm gonna pause and let you at your table, I'm gonna give you about 2 minutes to do E, F, G, and H, okay? If you get stuck, please do not hesitate to ask me, but please check with your peers first. All right, guys. All right, so for f of 0, you're gonna tell me, did you use 1, 2, or 3? For f of 0, you should have used 2, right? Because 0 is between -4 and 3. So you plug it in, so you have 0 plus 10 equals 10. For f of 3, what did you use? Shh. F of 3, you use, I'm sorry, 3, right? So we have 2 times 3 minus 6 equals 6 minus 6, which equals 0. For f of -100, what did you use? You should have used 1, right? So it's just 8, right? Because everything, that just means that from -4 and on, I just have a horizontal line going through 8. Does that make sense? All right. F of 100, you should have used 3. Good job. So that's 2 times 100 minus 6 equals 200 minus 6, which equals 294. Man, 194. I don't know how the 2. Ignore that. That's a 1. You never saw it. Never saw it. Boom. Okay. How do we feel about evaluating piecewise? Doable?
Yeah, doable.
All right, moving on. Now we're going to talk about part 2 of writing piecewise, okay? This is really important because you have a partner activity tomorrow that counts as 2 quiz grades, okay? And part of that partner activity is going to be able to write the piecewise function from a word problem. Does that make sense? You have to be able to write the piecewise function from a word problem and then evaluate it. So here we go. You determine your tax credit, C, based on your annual salary, A. If your annual salary is below 24,000, your tax credit is based on 25% of your salary. If the salary is between 24,000 and 50,000, the percent drops to 20%. If you make 50,000 or more, the credit is 14% of your annual salary. Okay. The first thing you want to do is identify your intervals. I don't know what it is. It was questionable altogether. Let's try that. 1. Okay. Identify our intervals. So the keywords when you're identifying your intervals are below, above, and between. Does that make sense? Those are going to be keywords that you're looking for. So we have below 24,000, right? We have between 24,000 and 50,000. And we have 50,000 or more. We see that? So our intervals and everything's in terms of A. So if your annual salary is less than 24K, that's our first interval. Does that make sense? And it said less than, so that's, notice how we put a strictly less than symbol. Then it says if it's between. So if A is between 24K and 25K, then that's our second interval. This one has to be equal since the first one was not. Does that make sense?
Wait, what?
Oh, 50K. Thanks. I'm going crazy.
It's okay, we do.
Well, it's not. Lack of sleep and a large to-do list doesn't add up very well.
In other words, what was?
To-do list.
Oh.
All right. And last but not least is 50K or more. The key thing here is or, right? That or lets us know that this one is the, yeah, I went the wrong way. Let's try that. Greater than or equal to 50K. How do you feel about identifying the intervals from the word problem? Doable? Okay. What happened? Oh, is that time? It's 3 o'clock.
Let me get my keys real quick.
All right. Number 2 is now you're going to write your expressions. So what are the expressions for those intervals? Okay. So when you are taking the percent of something, what mathematical operation are you doing? If I'm taking the percent of something, I am what? Multiplying, right? Multiplying by a decimal. So if I'm taking 25% of my salary and it says salary is A, what am I doing with 25% in A? It's going to be A times 0.25. And this is for anything that is less than 24K. Does that make sense?
Yep.
All right. Next one we had was 20%. And 20% was if you made between 24 but less than 50. And lastly, we had 14%. Okay. How do you feel about identifying the intervals and then writing the expressions?
I got a question.
Yes.
So if it's on the test, you're gonna ask us for those numbers over there. You're not gonna ask us to solve them, you just want those numbers.
It may ask you now that you have it, can you evaluate? Which is why we went over evaluating first. So for example, if I say my annual salary is 33,000, what is my estimated tax deduction? Which expression would you use to calculate it?
Yeah, the one with 20, right?
Exactly. So that would be the extent, after you write it, can you now use it? That would be the extension of it. Does that make sense? So that's why we went over evaluating before we went over writing. So I need to make sure you can evaluate before I have you create, then evaluate. All right, questions, comments, concerns?
No, you can forget it. But it's all good.
Okay. I have a headache too, I understand.
Me too. I'm gonna take a test all day.
I got it.
I know how to.
I'm riding the struggle bus with y'all.
My brain is fine.
All right. Ugh,
You know, bring the
Here we
cheese
go.
at the game.
girl. Here we go. Now, this time, instead of having a word problem to write the piecewise from, we have a graph to write the piecewise from. Does that make sense? Step one, why not? Instead of a word problem, you're using the graph. Oh, sorry. So step one is you want to kind of do a little bit of pre-work and you want to identify the type of functions you have. Okay, so reading from left to right, this is a positive linear. Agreed? Everyone agree? This is a positive linear. From here to here, this is a constant. And then from here to here, we have a negative linear. Agree? Okay, how do we feel about identifying? Doable? Okay, step two is you're gonna figure out your intervals. Okay, so from left to right, what is our first interval? Less than 2. So x is less than, and it's a closed circle, so we're gonna say less than or equal to 2. When it's a graph, we typically go from left to right. So whichever happens first is the one that gets the equal to. Does that make sense? Just like a book, we read from left to right. All right, what's our next interval?
5, 5.
Where's our next interval?
X is greater than 2, but less than 5.
Exactly. X is greater than 2, but less than 5. So X is, let me put it in the middle. We have X is greater than 2, but less than or equal to 5. Are we good?
I get it now. How do you know that? How do you know that 2 is?
Well, the
less
2,
than-
because from right here, what's the domain of this line, this constant? It starts where?
at 2?
And it ends where? At 5. Yes.
How did you know that it wasn't less than?
So the less than or equal to, because it's a closed circle and they're connected, you just use it as you're reading it from left to right, and you only can use it once. So I used it first here, the less than or equal to. So this one had to be strictly less than.
Why?
Because if they both are equal to, then it's not a function because you're defining it twice. Remember, x can't be defined twice. Vertical line test, no repeating x's. Is that ringing any bells?
I don't understand
Yeah,
why,
this is
but
algebra 2, but.
Algebra 2, algebra 1. Yeah, algebra 1 is, okay. All right. And then here, what do we have?
And
X is greater than 5.
X is exactly, so X is greater than 5. Not all real numbers because this is broken. We have specific intervals where things are happening. Okay? How do we feel about steps 1 and 2 so far? Okay. Step 3 is to now write the expressions. So we're gonna now write the expressions. So the first one is a positive linear, and for any linear equation, remember it's y equals mx plus b. So you need your slope and your y-intercept. For this line, Algebra 101, what is my slope? 2. I rise 2 and I run 1. Right? Agree? So the slope is 2. And then what is its y-intercept? 1. So can I write my equation? Yes. So we have 2x plus 1. That's our first expression. Cool? Okay. Next, for our constant, what is the y value of our constant? 5. So constant is done. Remember, a constant is just a number. Y equals a number. Huh? Left to right. Mhm. And then lastly, our negative linear. So this one, we can find the slope, but do we know what our y-intercept is? No, so we're gonna have to find that algebraically, okay? So the slope is what? We rise 1, run 1, so our slope is -1. So we know m equals -1. To find the y-intercept, you just gotta choose a point on the line. It doesn't matter which point you choose. Let's say I choose this guy right here, 6, 4. You choose a point, you use the slope, and you're gonna plug into y equals mx plus b. I'm gonna plug in y. What value of y is 6, 4? Which number, which letter is, which number is the y? 4. Our slope is what? -1. And what is our x? 6. So we have 4 equals -6 plus b. How do I solve for b? Add the 6, bless you. And so what is our b? This is literally algebra. This is not pre-cal, it's not algebra 2. It is algebra 1. That's all it was. You find your slope, you choose a point, and you use y equals mx plus b. You find your slope, choose the point, use y equals mx plus b. That's all we did. None of this should sound foreign or like the first time you've ever heard it. Today's still a very long day. So we have -1 is our slope, right? So we had -1x, and what was our y-intercept? B, which is 10. Whew. No, you're fine.
Please don't do a lot of them.
Out.
This is the last one. Yeah, Ms. Jones, you don't. It's just that one. I don't.
Okay, well, tell me where is this an issue? I will send y'all Khan Academy on slope intercept, because this is literally from algebra 1. You should have touched on it a little bit in algebra 2 when you're reviewing the beginning of the year. But after we talk about absolute values and solving systems, that's kind of it on the linear aspect. But as far as it goes, y equals mx plus b is all you did for the entire year of algebra 1.
Oh my God, that's what I want it to be.
Okay. That's beside the point. So, okay,
No, she says she hates teaching because she teaches algebra 1 professionally.
well, here we are.
She shouldn't have left.
All right, so, here we go.
Transferring.
G of x. So g of x equals 7 minus 2x, comma, x is less than 3. 1 is for when x is greater than or equal to 3. So we're gonna graph this, okay? So in order to graph this, the first thing we're gonna do is you're going to find your breaking point. So where does our graph break? I call it the breaking point. It breaks at 3. So 3 is our imaginary breaking point. Do the points have to necessarily line up on each other? Nope, but that's where everything begins. Okay?
How do you know that it's
Because our intervals, it's the number in our intervals. Step 2 is we're gonna plug in the breaking points. In this case, we only have 1. So we're only gonna plug 3 in here and 3 into here, which is nothing, right? So if I substitute 3 in for x here, what do I get? 1. So at 3, I have an open circle at 1. Does that make sense? And why is it open?
Because that doesn't have a line.
It doesn't have a line. It says strictly less than, right? Okay. Now on the second one, I can't really plug 3 in, but it says it's equal to where? At 1. So what used to be an open circle now becomes a closed circle.
Wait, why have we come full circle?
Because it says at 3, it's equal to 1.
Oh,
Okay. Step 3 is to complete the graph. So you're going to graph your expressions. Okay. How do you graph a linear equation? You use the what? The slope, right? And what is the slope of our linear equation? -2, not x, just the -2, right? So in order for me to have -2, that means I'm going to go up 2 and I'm going to go left. Does that make sense? Because if I go up, then that means I have to go left in order to be negative. If I go down, I have to go right to be negative, correct? So from my starting point, I'm gonna go 1, 2, and over 1. 1, 2, and over 1. 1, 2, and over 1. And now I have graphed my linear function.
So this is all good now, when you take the test, my brain just gets discombobulated.
Then 1 is just a what? 1 means it's a what? A constant. So 1 means it's a constant. And so that means it's just a line for all the values greater than 3, a horizontal line. And you just graph the piecewise function. This should have been your takeaway from yesterday's notes. Okay. All right, we're gonna do one more. And then I'm gonna be done. So the first one we have here, so it's following the same steps. We want to identify our breaking points. So our breaking points here are at 0 and 3. So 0 and 3. Okay, step 2 is we're going to plug in those breaking points. So we plug in. So when I plug in 0 to 0 squared, what do I get? 0. And is it an open or closed circle at 0? Closed. So I have 0. 0, 0, closed circle. Okay. From 0 to 3, it's just what? 4. At 0, what is it? Open or closed?
Open.
Open, because it says strictly, right? Open, because it says strictly. And at 3, what is it? It's also open. And these are going to be connected here in a moment. But all we're doing is plugging in our breaking points. Okay. Here on 3, when I plug it in, it's 3 plus 1 is 4. And it's going to be closed. Why is it closed? Because it has a line. It says equal to. Okay. So my teacher used to say the alligator ate a Snicker bar. And so it's full. So I go to 3, go to 4, and now it is closed. So I've now put everything on the breaking point where they belong. The final step is to graph everything. Okay. So here on x squared, if I didn't know what the parent function looked like, then I would just plug in what's after 0. So if I plugged in -1, I would get 1. If I plugged in -2, I would get 4. Does that make sense? So you're just finishing out the graph, and we know how to finish out graphs because we have been graphing for a while now. So there's the quadratic part. This is a constant, so it's just a straight line connecting them. And this is a line, and you follow the slope of the line. What is the slope of this line? 1. So I'm going to rise 1, run 1. Rise, run. Rise, run. And then I connect. And that is how you finish out the graph. Okay. So that is the conclusion of our piecewise notes here. If you need to, please go back and actually try to watch and listen to the independent lesson yesterday and go from there.